all know that weather changes, that clear skies become cloudy, that there are warm days and cold days, dry times and times of precipitation. What makes the weather change? The answer lies in air masses that form over different parts of our Earth. In the polar regions, air becomes cold. The slanting rays of the polar sun, even in summer, do not heat polar regions very much. But in the tropics, the nearly direct rays of the sun keep the land warm all year round, and the warm land heats the air that is over it. Our weather changes mainly because of air masses that drift away from the cold polar regions and the warm tropical regions. Within these two regions, there are 6 important areas where air masses develop. Air masses that form over land, called continental air masses, are usually dry, with less water vapor in them than maritime air masses, which form over the water that surrounds our continent. Let's look more closely at each of these air masses. One kind of continental air mass is called polar Canadian air. This air mass usually travels southeast across Canada to the northern parts of the United States. In summer, polar Canadian air breaks heat waves, bringing rain, then cool, fair weather. But in winter, polar Canadian air brings severe cold, producing the cold waves that can affect much of North America. While polar Canadian air masses form over land, polar Pacific air masses form over water. This air is not as cold as polar Canadian air, but cool and full of water vapor from the North Pacific Ocean. When the polar Pacific air masses reach the Pacific coast, the water vapor forms clouds that drop rain or snow on the high western mountains. Just as polar Pacific air masses usually move east across North America, polar Atlantic air masses usually drift east to Europe. Occasionally, though, polar Atlantic air masses move west to the coast of Canada and the United States. This cool, moist maritime air often causes fogs in summer and heavy snows in winter. Another kind of air mass, the tropical continental, forms over Mexico and the southwestern United States in the summer. Air masses that form over this part of the continent are hot and dry. As they move northeastward, they usually bring clear skies. Tropical Gulf and tropical Atlantic air masses form over regions of the warm Gulf of Mexico and South Atlantic Ocean and contain a great amount of water vapor. In summer, these tropical air masses are often the cause of severe heat waves as they travel northward across parts of the United States. Tropical Pacific air masses are also warm and humid. They form over warm parts of the Pacific Ocean and travel eastward to the Pacific coast of North America. As they cross the mountains near the west coast, they often produce rain or snow, moving on in an easterly direction. Tropical and polar air masses from these 6 regions are constantly in movement, generally eastward, across most of the United States and Canada. Most changes in weather come about when different air masses come in contact with one another. When a tropical Gulf air mass drifts northward and meets a cooler air mass, we'll find the meeting marked on a weather map. This line shows the boundary between the warm air mass on the left and the cooler on the right. Such a meeting, where warm air replaces cold air, is called a warm front. As seen from the side, the edge of the warm air mass slowly slides up, over the cooler air mass, pushing it back like this. The first signs that a warm front is passing over you are high cirrus clouds. Then you see lower cirrostratus and altostratus clouds, thin and flat. Soon the clouds you see are nimbostratus clouds. And finally, rain begins to fall. As the warm front continues to move past you, pushing away the last of the cold air, the clouds may get so low that they nearly touch the ground, and there is fog with the rain. When the warm front has passed and the warm air has completely replaced the cooler air, the weather is usually clear, warm, and humid. When a mass of cold polar air drifts south and meets a warm air mass, pushing it back, we may also find the meeting marked on a weather map. This line shows the boundary between the cold air on the left and the warm air on the right. Such a meeting, where cold air replaces warm air, is called a cold front. The edge of the warm air mass is tipped upward as the cold air pushes under it. If a cold front were passing over you, first you would probably see large, fluffy cumulus clouds condensing out of the rapidly rising and cooling warm, moist air. Then you would see thick cumulonimbus rain clouds that often bring thunderstorms, heavy rain, and strong winds. But soon the sky clears as the cold front passes and the cool air completely replaces the warm air. Now the air is cool or cold. A warm air mass can sometimes become trapped between two cooler air masses. This happens when a slow-moving warm front is overtaken by a cold front. The whole warm air mass is squeezed off the ground. Such a meeting of fronts is called an occluded front. High feathery cirrus clouds appear first. Then lower ones in layers. Then both nimbostratus and cumulonimbus clouds bring the storm, and heavy rain or snow can fall. When the storm passes, there are a few higher cumulus clouds and the weather is fair again. And so, across our continent, move warm air masses from the south and cold air masses from the north, changing our weather, bringing us the variety of weather that most parts of North America experience. Meteorologists today are working to gain a better understanding of weather and what makes it change.